All right, okay, so thanks everyone, and thanks Sam and Ellie for inviting us today. So I'm Phil McAleer, and along with Helena Paterson, we're from Glasgow, Psychology and Neuroscience. Just going to spend the next 20 minutes or so just sort of reflecting on some of the approaches that we've used within our teaching. Helena, change slide, please. Awesome. So for anyone who has come across the open science teaching we do at Glasgow, you're probably familiar with PsyTeachR to some degree. And if you're not, please do feel to check it out and give us some of your feedback on it. And really the outward looking face of what we've done is this collection of online interactive textbooks, which are really aimed at teaching data skills and statistical analysis using R, right? This isn't all that PsyTeachR has done, and Helena's going to show some examples of things we've done in terms of research methods, more kind of like what Julia was talking about. And she'll talk about that as the talk goes on. But this PsyTeachR and the data skills is probably what we've become most known for to some large degree. However, when thinking about how to tell someone to teach open science and reflecting on what we've actually done, we actually think this set of books largely hides a lot of the process we went through, and it might be difficult for anyone to look at this page and think where to start. So when we're chatting with each other and chatting with other people about this process, it really reminded us of the kind of the how to draw an owl meme, right? And what this meme really captures is the idea that people who are experienced in an area tend to oversimplify a process, basically because they've forgotten or they've kind of like cast to the back of their brains all the middle steps and the pain that they went through to get to where they are now, right? So for a lecture task with building an open science curriculum in their school, it sort of might seem like you've been given the circles, or you know what the circles are, and your head of school or whoever is now asking you to draw the whole owl, but you don't really have the experience or knowledge or how to do that. And what we know from our experience, and what's perhaps not seen by someone who's just starting out, is that much like preprints, teaching material in open science and all these kind of materials that people have put out there are the best example of them, right? They've been held off until they're a very polished stage. And we did that, right? No one really wants to put out materials that's not very good standards. So we've held off a few iterations and then made it available. So and then at that point, seeing someone else's material can almost become a bit of a hindrance rather than a help. And you get this sense that people don't really know where to start because it's just so much, right? So one key point to remember when kind of starting out in teaching open science is when thinking about building a curriculum, it really is a slow iterative process, perhaps with the help of a team or by yourself. And it's not meant to be an all or nothing overnight change. And I just kind of like thought about, so I led a lot on our year 2 undergraduate book, and obviously just remember in Scotland we have 4 years, but I thought about the process I've gone through with this book to get to where it's at now, and this slide really just highlights it. In the first iteration back in 2016, we had a straight conversion of our SPSS materials into R. And then after that year, we did an iteration where we started rewriting everything, every lab and every practical session that we did, to really focus more on the skills that we wanted to teach rather than the skills we had always taught. And then through feedback from students and pedagogical discussions in lab groups and kind of reading sessions that we had, thinking about things about usability of the material and interactive learning, we went through another edition where we added a whole bunch of self-directed learning material and then collated all these individual files. So every kind of lab we had was a separate R markdown file, and we collated them all into a book format. And that was a version we released about online at SIPS 2019. And kind of, yeah, by that point we were happy to have it released out and we were comfortable with the state it was in. But again, everyone had kind of not seen all the stages we'd gone up to that point and the mistakes, which we're happy to discuss later in the panel, that we'd kind of gone through at that point. And then since then, there's been another couple of rounds of edits and redrafts to the current version, which is version 6 now, called Analyze. But each time we're making small changes based on better understanding of our own practice and of how students have actually learned the stuff as we've gone along. So that was just kind of one book, and like I'm sure people are sitting there thinking, well, that's a hell of a lot of work just for one book. But what we did and what worked really well for us, we sort of took the team science approach of everyone bringing their skills together for the collective good, and we looked around our community within our school to see who could contribute what. We were particularly able to benefit from the skills and abilities of a whole bunch of people within our community, from head of school all the way through a team of lecturers, and including our amazing postgraduate teaching assistants who help in our labs, but also really thinking about our students as well and bringing them into part of the development process. We can teach, or we can claim to teach, as much open science as we like, but if it doesn't work for the students, it's redundant. So you also have to incorporate the students into your development process. And does it make sense for them? And you can see more about our approach in this online talk, which when we share the slides you'll have. That covers a lot more of the approach and how we did it. And that's not really what we want to focus on today, but it's there if you do want to catch up on it. But we're totally really aware that not everyone is surrounded by a team, or you're yet to find a team within your school. So perhaps making this kind of large curriculum change like we have, regardless of how long it would take, is not really a feasible idea. In that instance, what we recommend is just, it's worth thinking about the wider community that you're involved in, like Flavio's just shown, and what inspired you in that community. What things are you really interested in, like preprints, register reports, pre-registration, these sorts of things. And then thinking about what one class do you actually have control of, and what one thing can you change within that class. If you take the principle we took of the idea of teaching as a process of developing solid skills and knowledge, then giving students a solid basis in those skills has got to be better than teaching absolutely everything. And when we looked back at our curriculum, we realized we were over teaching on many things, and actually we were under teaching on things that we valued really heavily, like data skills. So we tried to focus on those ideas. And in this perspective, we really had to ask ourselves questions. Is it really important that we teach every single statistical test? Or can we replace that with some other skills, like data skills, like loading in data, like even just showing someone the layout of Jasper, showing the layout of RStudio or R, or comparing across different softwares? And what's really important is to also remember, and it's something that's come across in Julia's talk and in Flavio's talk, is that like it is incremental. One change leads to another. And really much of our change in the approach that we've done started with one of our lecturers offering the students in his class the option of taking R or SPSS to do their stats work, right? That one kind of decision really has led to where we are in our data skills teaching. There's a bit more in that poster link there. Again, you can get these slides after, but what I really just wanted to end my part on, it's really the idea that whatever the changes that you can do, and there's always going to be some change you can do, right? Either whether it's just like, as Helena will show, maybe changing your essay question to an open science essay question. You need to focus on what you can do and not what others have done, because I think looking at what like PsyTeachR could be off-putting to people. But also to remember that any change you are doing to teaching with open science, no matter how big or small that change is still teaching with open science. It's not all or nothing, it's moving in the right direction. So I'm going to pass over to Helena, who will show you some of the things we have done over the years.
Thanks, Phil. So my part is really where I'm just going to talk a little bit about some examples of assessments, basically, that we have used more than anything else. So open science is not just about these reproducible data skills that we've become well known for, but it's also about reproducible methods and how to avoid questionable research practices, and about communicating and writing up science to share it with other people. So we have incorporated into our curriculum what we do as researchers, and what I will talk about in this section is just the small or big changes you can make to incorporate open science into your teaching. The main message is that you can make these little changes that you have the power to make and build the bigger picture over time. As with Julia, we teach a lot of people that are not going to become researchers, but rather will be consumers of science. So it becomes even more important to teach people how to evaluate the methods and generalizability of research. Right back at the beginning, even before we made the wholesale changes to our curriculum, we were inspired by things that were happening in the research community. And they helped us to think about the authentic assessments that we could design to incorporate into our curriculum wherever possible. Why authentic assessments? So if you find things in the real world, so examples of something that happens in the real world, in the real research world, you can also find real world resources to help guide your students. And we found this really invaluable. So these assessments build independence and self-efficacy for students as they start to understand the arguments and ideas behind reproducible research practices, and also what the questionable ones are. And they can start to evaluate science from that perspective, but they can also start to feel part of the conversation about open science practices from the very first day that they walk into our program. So we weave these ideas into the fabric of our teaching, and I'm going to show you some of the examples of assessments that we've developed based around these things that we found in the community, just these gifts that people have given us. So as Phil noted, one of the things that I did right from the beginnings of when I first started teaching about this was to incorporate just simple things into essay questions. So this is one of the most effective and small things you can do. If you don't, for instance, have a big research methods course that you can teach. So here's how I've used essay questions to build skills in evaluating research methods and generalizability. So for instance, these are the questions that I used this year in social psychology exams, but they're very similar to questions that I've used in the past. Every year I reiterate and I change it a little bit. Another small change that you can do is that I try to incorporate learning objectives about open science into all of my classes, whether they are methods classes or whether they are social psychology classes or any classes that I teach. And this can send a really powerful message to students. But also the other thing that it does is that it helps you to build up a structure and picture of how open science is incorporated into your curriculum across different teachers. And if you're teaching in a large team as we do, different people can tap into these things and know what came before and what came after. But the other thing that it does is it provides this framework for you for teaching open science-based topics as part of the lecture course. Because these are learning objectives, that means that I'm going to have to assess them or in some way demonstrate that they have happened. And this sends this very powerful message to students and to other people that come and have a look at my materials that this is there. Something we did about 6 years ago, when maybe even a little bit earlier than that, when preprints started being a thing. Okay, so recently things have accelerated quite a lot, but right at the beginning there were relatively few people who were doing this. But we made this assessment based around preprints. This is an assessment that we developed as part of a portfolio for MSc students, and the task the students had was to read a preprint and pretend that they're a reviewer, and then write a review. Now, preprints don't have the same veneer of authenticity that peer-reviewed publications have, so students feel more comfortable in getting in on the conversation. It's sort of like it's already jumped a hurdle for them in terms of they're allowed to say these things and have this conversation. When we did this first, preprints were more variable in quality, and we could use them to teach students about better and less well communicated research. So there were stronger and less strong examples that we incorporated. However, in the time since, the quality of preprints have improved massively. There aren't people's first or early drafts anymore, but instead are much more polished pieces. So the task can be a little bit different now. For instance, you could give people a preprint and then say, if this preprint were to become part of the published record, what would be the contribution to social psychological knowledge base? Or and then people would read current research, see the publication process in practice, and learn about the topic with a bit of teacher guidance. So many wins in this, while they also feel less intimidated and more comfortable in critically evaluating a professional researcher's work. And I think this was something important for us to help students to get away from imposter syndrome. Are they good enough to be able to answer these questions? And our answer always has been yes. Given the right tools, you can get into the conversation. But this is just one of those tools that we use to help them feel a bit more confident about that. We were also really inspired by Registered Report. And if you registered reports. And if you have a little bit more space in your curriculum, you can start to think about how you can develop student writing and research skills a bit more holistically. Some of the central principles that we have is that we try to slow things down, build skills gradually, and emphasize practice for students. And we try to teach fewer things well rather than overwhelm students with a lot of stuff that they need to do. But registered reports were a real inspiration here, as they offer a clear example of how the research cycle can be broken into sections and how each section can then be assessments for students. For instance, one of the first assessments that when we first did the curriculum development, one of the first report the students wrote was actually a registered report, but it was only a stage 1 registered report. So we gave them some starter ideas, and they built these ideas into a research question and a justification for that research question, and then they worked on the methods. And then their task was literally just to give that to us as a stage 1 registered report. One of the biggest benefits of this was it gave us space to develop their writing. And then the first full report they wrote was actually a secondary data analysis with a known data set. And this gave us the opportunity to give students really difficult data to work with, dirty data to work with, data that real scientists had put up and used. And it was an important feature of what we wanted to teach them. We used data from the many labs, the psychological accelerator, and some gathered in-house by ourselves. And this helped to show the worth of the skills that we had been developing, showing that big data is really messy, and why the analysis skills that we were giving them would be so valuable when they see big messy data like this. That's very difficult to handle in Excel, for instance. And it teaches also that there are very different ways to do research. Not every single report is an experimental report. There are many different ways in which research is done. The other thing that inspired was pre-registrations. They've helped us to make templates for students, and they give a great example of how all the different considerations that you need in a methods and analysis plan. However, we discovered early on that they are very hard to complete for both teachers and students. So we use them to inspire us and to give ideas on how to structure peer review for methods, for instance, and also for analysis. And so we split it, this kind of thing, into 2 different sessions in semester 1, when people were doing that stage 1 report. We got them to peer review method sections for their peers, and in semester 2 they peer reviewed an analysis plan, and that was always one of our favorite labs to teach, because students it all just came together in that lab. All the analysis skills, talking about things like power analysis, how to visualize data, it all came together very well. So we kept the philosophical idea of pre-registration, if not all the mechanics of it. And the biggest benefits was the students discuss with each other their methods and analysis, using the language of their peers rather than trying to turn their language into something for a teacher. And once we get to dissertation students, they know this story so well that it helps them to manage their time and be much more effective in writing up their research. I leave you with a couple of student quotes here, just for the value that our students have found in these practices that we have been teaching for them. Thank you.